Quickly, because I'm not spending too much time here. 10 questions tomorrow, 29 points. Everything we've done so far, including today, will be on there. Reflection, can you reflect over any horizontal vertical line? So if it's y equals 3, is that horizontal vertical? If x equals 2, horizontal or vertical. Make sure we know that coming in tomorrow. Also, remember your rules for y equals x, flip the coordinates, and y equals negative x, flip and change the sign. And then probably what I'm most worried about is the day 2 honors reflections, where I'm going to have you reflect over a diagonal line. Okay, reflect over a diagonal line. So for instance, point A is negative 2, 3. I would like you to reflect that over y equals 2x minus 3. What's A prime? Where you go to your graphing calculator, put both in, find the point of intersection, and go from there. Okay, so make sure you look that over if you want to come in after school and go over some examples. I'm not going to put anything on Classroom because I just made one up here. You can just make them up. Pick up a random point, make your own lineup, and say, can you reflect over it or not? So that's all the reflections. Translations, I'm not worried about them, but I am worried you know the notation. Function versus vector. And then you got the capital T. Because tomorrow I will ask a problem or two where it's like, all right, here's triangle ABC. Here's triangle A prime, B prime, C prime. I did a translation. Describe the translation in function notation. Do we know how to leave that or not? All right, so that's up to you. And then what we did yesterday, rotations. 90 is counterclockwise. Negative 90 would be clockwise. And then what we're about to do right now. So that's what we're looking at for tomorrow. You will have an extra sheet of graph paper at the end if you choose to turn your paper at all for the rotation, so you don't need to memorize the rules unless you want to. That's a personal decision. Anything? And tonight's homework is pretty much a little bit of a review. Last call, anything here? Because I'm just checking homework and going over it tomorrow, and then you're going to start. Again, this is what probably I'm most worried about right here, the old honors one. All right, let's get into today. Day 2 of rotations, but a little bit of an honors level because no more 90, 180, 270. It could be any degree measure I want you to rotate. And we're not rotating points either. We're going to rotate figures. All right, so first one right here, I got myself a regular pentagon. Timeout. Go back to Unit 4, Day 1, Unit 4. Regular figure, what do you know about it? If a figure's regular. All the sides are equal, and more importantly right now, all the interior angles are equal. Correct. So that means right up in this pentagon, congruent, 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 and congruent. Because look what I'm asking you to rotate. Take point E for me and rotate it. Whoa. 72? We're good with 90, 180, 270 because we can just turn our darn papers. But 72? That's a problem. Well, first, am I going to go clockwise or counterclockwise if it's 72? Counterclockwise because it's positive 72. Good. So I know I'm going this way, going to the left, taking point E and rotating it to the left. But 72? 72? If you add up all 5 of these angles, what should they all add up to? Going all the way around, it should add up to 360. And what do we know about them? They're all congruent. Yeah, get your calcs out. I'm not doing this calculation for free. Let's find out what each angle happens to be. So they all add up to 360, and all 5 are congruent. So each angle is going to be 4 when you're ready. 72. Look at that. So every time you rotate, you're going 72 degrees. Right? All right, now let's actually answer this question. So if I start at point E, rotate it 72, I'm going to end up, and this is why it's good to know if it's clockwise or counterclockwise, what point you're going to end up with? 5, point P. There it is. I end up at point P. Everyone's all right. All right, now let me up the degree measure. Now we're going to start at point P now and rotate it 216. But I only rotate 72. How can I rotate 216 then? I only can rotate 72. But if you rotate another 72, how many total degrees have you gone if you rotate a second time? 144. What if I rotate for a third time? I've gone through 216 degrees. Yes, it's a multiple of 72. So I end up at point 18 N. Yep, point N. If I rotate 3 times. Everyone seeing that? P to A is 72. P to T is 144. P to N, 216. Questions, comments, any concerns yet? All right, pentagon. Let's go to an octagon. 8's up. Anybody? 8 sides? Yep, you got it. All right, well, this isn't going to be 72 degrees anymore. As I go from one vertice to the next, let's figure out how many degrees I'm going so I can answer these questions. Because it's not 72 anymore. I'm in an octagon now. So I'm taking that 360, dividing it by 8 congruent angles now. Whoop, and I just totally botched that. 8 congruent angles, and I end up with 25? 45 degrees every time. So every time you're going to rotate 45 degrees. So now knowing that, you and your group, go ahead, 1 through 6, roll through them. If you rotate 45 degrees every time.
Yep. Put that top one there. Where's the top one? Put it wherever. Did you do that? It's your chance. Okay. That's yeah, like how you boys on Visual discussion question in English. Yeah. What discussion question are you doing? For the essay or for
It's kind of based off the family thing. I'm basically trying to prove something about how relationships and families cause death.
Hey, here we go. Let's roll right through these. Number 1. 3. What do you have? I. Yep, we end up at I. Second one. Who do we got here? 28. Yeah, I. And 6. For question 3. I again. Yes, I'm sensing a pattern, but it ends at right here. Since I'm rotating a segment. Already heard. 3. GH. If anybody is having a problem rotating segments or reflecting anything with the segment, reflect it, rotate it, take each endpoint separately. So do it to E first, do it to I, and then connect them, and you got your segment. But GH, good job. How about question 5? 21.
G.
G. I don't even know why I ask number 6 all the time, but I do. 10.
ST.
ST. You end up right where you started. Everyone all good? All right, let's take the degree measures out of it now. Let's go to this regular hexagon. Actually, I will need the degree measures, 180. Reflected over BG. So everyone take triangle ABG. We're going to take this triangle right here, reflect it over line segment BG. I'm going to reflect it over there. That's the first thing I'm doing. So I need from somebody, not my final answer, of course, but what triangle do I end up doing when I reflect it over that line segment? 19, BCG, one right here. Good. And then are you ready? Now rotate it 180 degrees around point G. So point G is going to stay where it is. Where would B and C go then to form my new triangle? 180. Remember, it's a hexagon, right? So just like we've been doing, 360 divided by 6. Each angle is 60 degrees, if that helps you. 180 degree rotation. We end up with what triangle? 22?
GFE.
GFE. Thank you. Good deal. All right, great. Move. Ooh, all right, now a little equilateral triangle. I'm going to rotate it clockwise. What's the minimum number of degrees I can rotate it to carry it onto itself? All right, little vocabulary term up there. Carry it onto itself. What do you think we're looking for here? How many degrees for it to do what? Carry it onto itself? What do you think there, Nick?
And then to rotate and be straight on the other bases.
Everyone see my figure you're looking at now? How many degrees can I rotate that so I get that same figure back? Not tilted a little bit one way or the other. That same looking triangle back. Now, is the answer 360? Yeah. If I rotate it all the way around, I'm going to get it back. But look at the language I put in here. I don't want 360. I want the minimum number of degrees. There's actually a degree measure or 2 degree measures less than 360 that could get that same triangle back. So does everyone see my goal? How many degrees can I rotate this triangle so I get this one back? And I know a lot of you are thinking, oh, I'm just going to do... Nope, I'm not going to say it. Don't want to say it. Thoughts? 360 is an answer, but they're smaller. There's something smaller out there, and I want the smallest one possible. If I go from there to there, I'm going to get that same triangle back. Here to here. How many times should I rotate this to get back to the very beginning? To get back to the very beginning, how many times would I need to rotate it? 3, right? And 360 degrees. So what's one of these rotations going to be then? 360 divided by 3? 120. What else would work? 240 would work. 360 would work. But again, I got to follow directions and say what's the minimum.
Mr. Galino?
Yeah.
It says clockwise. Would it be negative 120?
The smallest. Well, here's. Okay, you got me there. Clockwise. Okay, I never even thought about it. So if I go, but here's the thing: the minimum number. I got to change that then, because it can't be minimum. Because negative 120, you could go negative 240, and that's still smaller than that. We could keep going. We could go pretty deep here and just keep adding negative 120. So the minimum number of degrees. We got to change that next year. We got to put counterclockwise in. Because there's more minimum than negative 120 though. That's the thing. So I don't think this question could be answered the way we worded it. Okay. I'll just leave it. Because everyone see, if I leave it at negative 120, that's false because negative 240 could also do it. And that's still not the minimum because we could keep adding negative 120. So I guess there is no minimum to go clockwise. How about we just change it counterclockwise and then we can keep our 120 there, huh? How about that? There we go. There's an adjustment. Counterclockwise. Now we can keep our 120. Oh, love 9. Here's your rectangle. I got 4 choices. Which one of the 4 will not carry it onto itself? So I get a different looking rectangle back after I perform one of those 4. The other 3, I get that same looking rectangle back. So let's start with number 1. What happens if I reflect it over the line y equals x? Oh, great review for tomorrow. What's the rule again? Y equals x? Going into tomorrow? Flip the coordinates, right? Flip the coordinates. All right, so real quick, what's point A here so I can do that? Point A, anybody count it over? 7, 1, so that would go to where? 1, 7. What's that 1, 7? What's that 1, 7? D, right? So A would go to D, D would go to A. Where would B go? The C, C would go to B. Does anything change? Nope. So that's not gonna, that will carry it onto itself. I'm looking for which one will not. Ooh, how about this one? A reflection over y equals negative x plus 10. Can we get a quick visual of what that looks like? What's the y-intercept so I can graph it real quick for you? 10, right? All right, go up to 10. 1, 2, 3, 4, 5, 6, 7. Yep, it goes up here. What's the slope of this line? Negative 1. So where can you tell me to go make a couple other points here? Down 1 over 1, down 1 over 1 right here. Everyone see this line I'm making? All right, where would point A go if I reflected over that line? Point B, where would C go? Am I going to get a different rectangle? Nope. All right, see ya. That's gone. That's gone. All right, so now I'm down to these rotations here. Rotation of 180 around 0.66. Locate 0.66. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Right here. I missed right. Is it right here? 1, 2, 3, 4, 5, 6. There we go. All right. Where's point B going to go if I rotate it 180 around that point? Point C. Yeah, where's C going to go? B. Ready? Where's A going to go? Not to D. If I rotate, 180 is directly on the opposite side, right? So point A is going to go, if I go somewhere over here probably, A prime. Where's D going to go? Not to A. D is going to go somewhere over here. So am I going to get a new looking rectangle back? Sorry for the yelling. We had some people in here think it's nappy nap time. Not 9th grade anymore. All right, maybe back in daycare. A prime or D prime? Everyone see I'm going to get a different rectangle? Okay. So I still want to go over why 4 would not change it though. What is the difference between me putting the point at 6, 6 to 5, 5? Look where 5, 5 is. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Where's D going to go? If I rotate it 180, where's D going to go? B. Where's C going to go? Okay, I get the same rectangle back. That's the difference going from 6, 6 to 5, 5. All right? Oh, now now I'm all awake. Now because I get no homework. All right, let's go. Let's go. I'm going to start putting a time limit on this too.
Slide right.
Oh my God.
Slide left.
Spin. Drop it. Drop it. Buck.
Shatter.
Swing.
Pinwheel.
White.
2, 1. Last ones.
Q.
We're closed. Here we go. Genie. Stars. Curl. Drop. Clock. Fade. Swing. Cube. To the right. Left. Spin. Pinwheel. Book. Shatter. Curtain. Swipe. Or white. Sorry. All right, here you go. Curl it is. Or Promethean Man. You guys can tell I don't have any more slides here, so we'll back up one. Here we go. Curl or Promethean Man. We ready to get this done? Drop. Almost. Almost. The 4 would drop. Almost. All right, here we go. Let's get moving. Line H. Line H. 2x plus y equals 1. All I have done with you guys is rotate points. Can we rotate a line? Darn right we can. Because a line's made up of infinite amount of points, so why not? So 2x plus y equals 1. I want to rotate this 90 degrees. I want to rotate it 90 degrees. What's the equation of the new line? And I just want to open it up to you guys where you want to go from here. Take that line, rotate it 90, and what's the equation of my new line? Because it's not going to be 2x plus y equals 1 anymore. Anywhere you want to start? I want to listen to you guys here. I just don't want to go, this is that. What's up, Will? Yeah, all right, yeah, why don't we do that? That's what we're used to, right? Move the 2x over. So y equals negative 2x plus 1. All right, we're good. Why don't I put the graph there, right? I know it's optional, but hey, why don't we take a look at what this bad boy looks like? 1 on the y-axis, and then where should I get some more points? Down 2 over 1. Down 2 over 1, yep. So this is the line I'm asking you to rotate 90 degrees. $90. I don't think I'd ask you to rotate at 180 because I think we'd be on the same line, right? The points would just be opposite each other. That would be the same line. 90. 90.
Negative reciprocal.
Why? Because these two lines are going to be what to each other? Perpendicular. All right, let's start there. What's the slope of this line then? Negative 2. So the slope of my line, if it's going to be 90 degrees and perpendicular, will be? All right, we're halfway there, right? I know the slope. What's the other thing I'm missing? Y-intercept, right? And this whole time, this whole year, in fact, we've gotten the y-intercept by plugging into y equals mx plus b. What value do we definitely know? M is 1/2. And what do we usually plug in for y and x? A point we know is on this new line. So I don't want to use any of those. I want a point on my new line, though. Yeah, good idea, Ellie. Rotate your paper 90 degrees, and you'll see all the points you want on the line, right? Everyone go ahead. Rotate your paper which direction? Which direction are we rotating? Counterclockwise. So everyone should turn your paper once to the left. That's what your new line will look like. Give me a point off that new line now that you definitely know is on there. I've heard, what did I just hear there? 1-1? 1-1 works? I think last class we used -1, 0. That also is on there. If you rotate it. So 1, 1 would work. So plug in 1 for y and 1 for x plus b. Is everyone all right how I'm using? I know 1, 1 is on there. We literally turned our paper to the left, looked at these 3 points we graphed, and one of them was 1, 1. You could have used a couple other. All right, so go ahead, find the y-intercept. Y equals 1/2 plus b. Move the 1/2 over. My y-intercept will be 1/2. All right, so what's the equation of my rotated line, which we're calling line H? I'll start it off. Y equals line H. Okay, 13, put them together here. Y equals 3.
Y equals 1/2 x plus 1/2.
Thanks, Kyle. So yeah, we can rotate lines. Questions? We sure? What if I said 270?
It's the same thing.
Same line. 1/2 x plus 1/2. Yeah, if you rotated it 270, it's the same line. Check it out if you don't believe me. All right, in your groups, number 11. This is where we'll end it. Number 11. Talk it over. Talk it over.
Oh yeah.
I mean, unless having like a triangle, like, I mean, don't say many on the same side. I was just wondering if like the triangle itself is like a different angle. But no.
T, they
Yeah, so it just
You circled 2 answers.
I know. I always
And finally, line reflection. We changing the side length or angle measures. Translation, sliding. Does it matter if I slide up, down, left, or right? Am I changing the sides or the angles? So definitely congruent. And we've learned all year long if 2 figures are congruent, they're also similar. So there we go. The assignment is not out of the book. It's right here in the packet. It's a review for tomorrow's quiz. So don't be surprised if you see reflections and translations. Remember, hey, you have scrap paper in the back if you need to use it. You have scrap paper in the back of your packet if you need to use it. All right, let's get it going.